Hello everyone, this is your professor Jason Fleischer and welcome to our first lecture. Pandemic lectures are obviously going to be quite a lot different than the ones we're used to, and I want to thank you for showing up, for being part of my course, and for dealing with all the stuff that's going to go wrong with us this quarter, like my cat already showing up. All right, Magic. All right, that's your cue. Go lay over there. Right, so here we are. This is COGS9. It's an introduction to data science. It's a course to survey what data science is and all the different things that make it up. Let's head on over to some slides. There we go. Let's just get the general stuff out of the way first, the bits and bobs of how we're going to make things work. So first off, I want to introduce you to our instructional team. If you look on Canvas, you will find a set of videos where everybody, or most everybody, gets a chance to introduce themselves, and you can find out a little bit more about us as people and the research that we've done that make us experts in this field to be able to teach some of it to you. So our TAs are Asheen, Avinash, and Vicky. They will each be taking 2 of the discussion sections. And we have 3 instructional assistants, Stephen, Min, and Chen Hao, and they are, I believe, I think that all 3 are actually not in the US, so they are in time zones that you may be in, and they're going to help out a lot on Piazza, answering questions when it's Asian daytime, and they're also going to be available if you have questions directly in email. They'll also be doing some grading for you. So, other important things, maybe the one thing that you may most commonly hear when you start a course in any university class: please read the syllabus. Please, please, please. And when you have a question, read the syllabus. I know, it sounds a little harsh, but when you're running a 300-person course and 60 people ask you the same question and the answer is in the syllabus, you may understand why we say this over and over and over again. There are no dumb questions. Everybody has a valid question, but if the answer is in the syllabus and you send it in an email to 4 people and they all take their chance to respond to you, well, there are maybe dumb ways to ask questions. So overall, because it's pandemic land, which is not as fun as zombie land, there aren't really very many expectations, but the ones that we have are non-negotiable. We do want you to learn. We don't want you to cheat. We do want you to work. We don't want you to break yourselves dealing with weird time zone issues, or the fact that you have a job and can't make these discussion sections or something like that. So what we do expect is that everybody will do their best to make this work and to learn. What you do with your time, exactly how you spend it, is up to you, because you're a big adult, you get to make choices. But it is important that you actually okay, already decided to stop working here. Let's see. All right, we'll go with this. So there we go. We need you to know when you need help and to seek it out. So if you have questions, if you can't figure something out, if it's not in the syllabus, please ask somebody, ask 2 somebodies. Ask whether, okay, in lecture is an old bullet point there, but ask in Piazza, right? The Piazza is an excellent resource. It's going to get you not just answers from the instructors, but from your other students who may know the answer, and they're right there online, and they're going to give it to you faster than we get around to it. And know that if you do have this question, of course, other people are going to have the same question too. It's inevitable in a course of 315 people. So, let's see here. Brilliant. Okay. Technology is already doing its technology thing. So, I want to point out this article in the New York Times from a few years ago. It is really quite cool. The reason I'm bringing it up is that I'm sure that probably a third or more of our course is freshmen. This is maybe your first quarter, and it's a scary time to be a freshman. So this is a great article with lots of advice from people who are just graduating to people who are just starting out. And I'm not going to go through it, but the topics are there, and roughly speaking, they are, learn new things you wouldn't think you were ready to learn. And I think a very big point to highlight is this bullet point of understand the system and how to work it. The university is a very big bureaucracy. There are people here who cared very deeply about your success. There are also bureaucrats who could not care less. And understanding who to go to for advice, who to go to make something happen that you need to have happen in the bureaucracy, these are big, big deals. Become friends with your friendly administrator, okay? Become friends and, try to be nice to professors who demonstrate that they care about your success. Understand that some professors won't care about your success because they're essentially running $1 million a year small businesses in their research labs, and they have no time if you don't contribute directly to their research success, okay? But again, people care. Some people care deeply. Some people care just that it's their job, okay? So learn how the system works. That is one of my big advice to anybody who is just starting out here. Please do tend to yourself, especially in pandemic times. Sleep is a super important deal. Some of my research actually has to do with sleep, and it is very clear that if you don't take care of yourself physically with a bit of exercise and more than enough sleep and some decent fuel, you're not going to do as well academically. And you're going to feel terrible. And people skills are a great thing to develop. So beyond this article, a few other bits of advice from me. Your GPA is not what you're after here. The GPA is a tool to accomplish what you want to accomplish in life. It is super big deal to find mentorship, to find the people who are going to help you become a better you and become what you want to be. You'll be surprised at how often people are willing, when you ask them nicely, to help out, especially when you flatter them a little bit. So take electives from professors who you find interesting and talk with them, because in these small courses, you're going to get a chance to interact and you're going to learn stuff that you wouldn't in big courses. You're also going to maybe get research opportunities if that's or opportunities for letters of rec. In a course like this, it's going to be hard for me to write a letter of recommendation because you're one of 315. But if you were in a small course where I was interacting with you and 10 other people, that's another case, right? In the data science and Silicon Valley kind of world in general, things are very project driven, right? Go out there and start projects, start new things, get involved with things. Don't feel like you have to take it to some sort of, and I deployed the software and made $1 million with it. Lots of projects don't lead anywhere except to the next project, which eventually leads to maybe that success that we were just talking about, okay? Another Silicon Valley kind of thing is to set goals, but be ready to change them. When a venture capitalist gives $1 gazillion to a startup, they only do that when the startup has a clear plan about what they're going to accomplish. But on the flip side, the venture capitalist knows and has become comfortable that the founders of the company understand if they're not making money in 2 years, that they're going to completely change the direction of the company to try to make that money. So you've got to reevaluate your direction once in a while, and sometimes you may need to change everything. And again, there's no such thing as a stupid question, but there are wrong ways of asking it. So that's the boring stuff out of the way. This is the stuff we actually wanted to talk about, right? What is this course? What is data science even? Because it turns out that there's a bunch of debate out there about what data science is and what it isn't. I mean, is it only data science if you're using Google-sized data sets? What even is big data? What's the size? Where's the threshold? Is it really new? Is it different than what, somebody in the 1980s was called a business analyst? Is that different, or is just the tools different? So overall, I do want to emphasize one thing, which is that data science is not the same thing as machine learning, okay? Many people who do machine learning are not data scientists, and many data scientists may do something that's no more machine learning than, that business analyst in 1985 did, okay? So they're both buzzwords which are out there and people get excited about, but they are actually different things, and we're going to try to explain that to you exactly how that difference works over the course of this quarter. So let's look at another way to define what data science is rather than saying what it isn't, okay? A lot of people talk about it as this intersection of a unique intersection of many things that have been out there in the past. There have been people out there for decades and decades who have lots of math and statistics abilities, and they applied them to make things work in business or science or stuff like that. The Rand Corporation became this immense force in US history because they had people who knew statistics and knew how to apply data to make decisions, right? But that field only vaguely overlapped with computers, with the hacking skills, with the ability to use machines to create large-scale systems that could solve problems from data in ways that certainly couldn't be done in 1970 and could only be done, to be honest, since the 2000s at all. And the final element of this, besides the math and the computing, is actually understanding the topic that you are crunching numbers on, okay? Numbers are just numbers. If you don't understand what they mean, it's easy to make mistakes with them. It's easy to assume that something is a good measurement of something when it's actually a really, really poor measurement. It's easy to make mistakes if you don't have some sort of domain knowledge to the problem you're trying to solve. So there is now, if you go on any of your job sites and search on Glassdoor or something like that, there's going to be thousands of jobs that say data scientist in them. There are going to be very, very different jobs, actually, even though they have the same title, and we're going to talk about that in a minute. But we now have a data science major for the last year and some, and it's a joint effort between computer science, math, and COGS9 to try to train up these elusive data scientists. I think all this kind of really kicked off with this report in Harvard Business Review. It's one of those magazines that's read by people who are CEOs and, wannabe CEOs. And it's really kind of like the academic journal of the top end of the business world. And when they proclaimed in 2012 that data scientist was the sexiest job, that really set off a bunch of things, okay? It set off a craze for people to go, oh yeah, if we had really good quantitative thinkers, we could do so much more, and started people being more interested in hiring that. It also started a lot of people turning job listings that had previously said things like business analyst into data scientist, even though they're really the same job. So, so that's where we get to this crux of, arguing about whether data science is even really a different thing than what had gone before. Um, we're going to read this paper. It's one of the readings. I've already forgotten when it's due. I want to say a week or 2 weeks, but we'll find out when you look at the syllabus. This paper, by David Donoho, The 50 Years of Data Science. And they talk about the fact that this is a coupling of scientific discovery and practice that involves collection, management, processing, analysis, visualization, and interpretation of vast amounts of data. I want to highlight some things in that. So some data scientists are mostly doing pipeline. They're doing the collection, management, and processing of data. They're essentially doing software stuff, right? Some data scientists are doing analysis. They're doing the thinking, what does all this data mean? Some data scientists are more doing the visualization and interpretation and communication. They're taking the results of those analyses and trying to convince people who make decisions, hey, this is what's really going on out there. So 3 very different domains right there. And oftentimes you find that people do a little bit of all of this. I am happiest when I'm doing a little bit of all of it. But there are definitely specializations out there. I want to highlight, let's see if my thing's working now. Nope, still not working. Okay, so I want to highlight this down here, the Brad Wojtek quote. He's going to come in with the study of how the quantification of observable phenomena can lead to human understanding of the processes that give rise to the phenomena. This is a really subtle definition, by the way. I want you all to sit with that for a bit and come back to this maybe. So we observe things, we can quantify them, and somehow that's going to give us some understanding of the hidden processes that gave rise to the things that we can observe, to those phenomena. That's where some of the subtlety comes in. And even the ability to predict future outcomes without us actually understanding those processes. We have a black box. It does things. It makes us, makes our sales better, but we don't understand what's in the black box. And also maybe in an ideal world, maybe it tells us something about why certain phenomena require more or less data to lead to this understanding or prediction accuracy. So I'm going to kind of summarize all that data science in a high-level description is the scientific process of extracting some kind of value from the data. And that can go about it in many different ways. Now, here's the part that you may really like to see. It is a very, very good job. There are thousands of openings, and I'm sure that's why a lot of people are interested in this data science degree. And the median salary is really quite nice when you just talk about the base salary, the starting salary for somebody coming out of school and into an industry job. Now, I'm going to say that base salary is got a lot of variability in it. There are people who make much less than that and people who make much more. And what exactly a base entry-level data science position is very different. Some of them are people who just came out of school with an undergraduate degree, and some of them are PhDs. So, right. What do data scientists actually do with their workday lives? We could, take the high-level descriptions. Data scientists ask interesting questions and answer them with data. I'm going to say that it's more of a mindset of thinking quantitatively and how to think about things with quantitative information. And that is what data scientists really spend their lives doing. So let's get a real example out there. So how can I succeed with my date? How can I get to be a better match with them? What kinds of questions should I ask to find out if there should be a second date? One of the big deals in the data science community back in 2011. I was going to say 2013, but was OkCupid was one of the big dating apps back then. And they had a data scientist who had this great blog that was anonymizing all the stuff that people were doing online trying to match up with each other and bringing out interesting questions about, how people were finding their ideal mates. So, people in OkCupid land, they were doing all these questions. I don't know if you've ever seen the site or the app. They would ask each other questions and they would try to match up with similarity on many questions. Fun fact, I met my wife on OkCupid. So let's take a look at how this whole thing worked. They took all these hundreds of thousands of questions and they had to get rid of most of them because most of them are dumb or they're way too personal or they're obvious in their results. And you need to have something which has a little bit of leeway for answering. And they came up with about 50,000 out of almost 300,000 questions. So that was like a big human filter on the front end. And that's one thing to note, is that in data science, there's often a lot of handwork. There's often a lot of people actually just getting into the data and doing things by hand before the machines take over. So you want to know, do I and my date have long-term potential? So it turns out you can ask 3 questions that can actually be very predictive of whether you will stay together for long periods of time, for months at least. Do you like horror movies? Have you ever traveled around another country alone? And wouldn't it be fun to chuck it all in and go live on a sailboat? So these 3 questions are the ones that they found to be most predictive of months of dating success. Now, this is in contrast to the ones where they asked people, hey, OkCupid users, which 3 questions do you think are going to best predict whether you and your mate are going to have long-term success? And they said things like, is God important? Or is sex important? Or does smoking disgust you? So when you look at this bar graph here, what you can see is, so these are the users' belief in what are good questions to predict mating success. And this set of blue bars, the low light blue bars, are what you would predict by chance. Just that in general, there are, even if a question has no predictive accuracy, by chance, 5% of the time, it's going to be correlated with success. Okay? We're going to get into this kind of concept as we get more into statistics. Okay? This is how much predictive power you actually had, that people who matched in is God important in your life, whether they said they had the same answer to that question, they were together for months 15% of the time. Okay? So it is better than chance, but it's not a lot better than chance. That is the element right here, is how good is this at predicting success. Now, on the other hand, the 3 recommended questions about sailboats, horror movies, and traveling solo in another country has a lot more predictive success. Okay. So that gives you a flavor of how all this, data science-y stuff works. Let's go a slightly different direction. Another thing about data science is it's often concerned with internet data. The OkCupid example was also like this. The internet is this crazy source of terabytes and exabytes of data, okay? When you have enormous amounts of data, it can lend you to finding really interesting correlations that would not be visible when you did a much smaller kind of data collection. And so Facebook is one of these places where people are very, very willing to share all their data, sometimes very private data. And they took a look at migrations. When somebody had a hometown and a current city that were different, they could look for patterns of migration. Lots of people that left that hometown and went to that particular city. So they did a bunch of things to try to study this, because they had millions and millions of users who gave this data. They were looking at the aggregate anonymized data. They weren't looking at Joe, who left Olathe, Kansas, and moved to Abilene, Texas. Okay, they're looking at patterns of how many hundreds of people left Olathe to move to Abilene. So when you do that, you get very interesting results like this. Slides only. So worldwide, there are very, very interesting patterns of migration. To kind of give you an idea of what's going on here, you can see, like, let's look at India, okay? India is a great hub of movement internationally. People are moving to and from India from Africa, from Turkey and that area, from elsewhere in the East, and also I know it's hard for me to see on this, but there's definitely got to be a movement to the US as well. The another thing to look at is we can zoom in a little bit inside Africa itself. And when you zoom in a little bit, you can see not just the big international migrations, but you can see there's a strong pattern of people moving from all these little dots, these little tiny towns, to the big, growing, developing, rapidly urbanizing cities like Nairobi. This is a very common pattern across the world, this moving into rapidly urbanizing areas. You can also see about different types of migrations in the US, coming into the US. It may be no surprise to you that a very large chunk of migration comes from Mexico and Cuba. And in this way, you can, so we get into one of the troubles here with data science, right? People will look at this and go, no duh, I know this happens, right? Everybody talks about it on the news. But the thing is that lots of things happen in the world that people assume to be true. But until somebody actually gets in and measures it reliably and repeatedly so that we can have confidence in the measurement, you don't really have a strong, just because some talking head says it on TV doesn't mean the truth is actually that, right? So that's where I'm, oftentimes people can dismiss the results of science or data as saying we knew that, but indeed we didn't know that, people just said it, until somebody actually makes a good quantitative study of it. So let's do another example, the gig economy, ride sharing, Ubering, something that is maybe a little bit on the down recently with the pandemic. So when Uber first started out, they were in San Francisco only. And when it was in the first year or two, they did this study. Brad Wojtek, who was actually the founder of this course, COGS9, he actually worked for Uber before he came to UC San Diego. And this was one of his studies where he was looking at why did somebody cancel their ride? Maybe they called for a ride and they didn't, after a certain amount of minutes, they canceled it. Was it because they were getting upset that they were waiting too long? And this data kind of shows that there is strong evidence for that being the case, right? So the business Uber knew from these results that they had to do better in getting their drivers to their customers much, much faster. So how does this graph show us that what I just claimed it did, right? What you're seeing here is when somebody has completed their ride, they called for an Uber and they got in it and they got to their destination. These are how many minutes they waited. So there were relatively few people who were waiting 10 minutes after calling it who completed their ride. Okay? And there were a lot of people who were waiting about 4 minutes who later completed their ride. That's what that graph shows you. Now, if they canceled the ride out at 10 minutes, there were many more people who were going to cancel their ride and had waited at least that long. So this is how this kind of a graph demonstrates to us the nature of the problem. It gets more complicated because the data always do. When you look at as Uber gained more and more success and got better and better at providing quick rides in many cities, people's expectations changed. And when you look at the 60th city that Uber started out in, then people's expectations of getting a ride quickly became higher. This is the decay rate, and a smaller decay rate leads to a less patience with a slow ride. Okay? So you can see that in this graph. Here is how long people were willing to wait in 2013, and in 2014 it shifted to the left. They were less likely to wait. Okay. So those couple of case studies just give you a flavor of the kinds of activities that data scientists engage in. They could do all kinds of things, anything on this list. It doesn't mean, just because you're a data scientist doesn't mean you're working for Silicon Valley. There are many people in government doing it, people asking interesting questions in science, people who want to help out political campaigns by figuring out how to best use the money to get the result you want. So data scientists work all kinds of places. An early adopter was Amazon. And I'm guessing that most of you are too young to remember the beginnings of Amazon and when its webpage looked like this. But they they realized very quickly that using quantitative methods and people who knew how to use data and computers could help make their business more efficient. And they used that ability to branch out into actually becoming suppliers of the infrastructure of the internet. That would be AWS if you're not familiar. Airbnb, Lyft, Uber, companies like Stitch Fix, whose deal is actually interesting because it's a weird agglomeration of humans and computers. If you're interested, you should definitely take that algorithms tour because the computer algorithms are helping humans make better decisions in an interesting way. And it's not just Silicon Valley, it's the giant big businesses too, like Shell and Dr. Pepper Snapple Group, who are also snapping up data scientists to help their systems do better. And the cat's back. So another thing is that data scientists also work in kind of what you'd think of as public service fields, right? In journalism, there is becoming more and more a need for people who really can do data science to help, for instance, go through huge dumps of leaked documents and try to understand the complicated financial industry shell games that the rich use to hide all of their money. Or to maybe make live maps of where wildfires are so that the readers of a newspaper can avoid the problems. Okay? So there is a real need for data scientists in all kinds of fields. Now, remember that Harvard Business Review article I showed you about data science being the sexiest job in 2012? Well, more recently, there's a very interesting piece that I do recommend that you take a look at, which lays out a kind of, again, this dichotomy that I was hinting at earlier, that data science can really be seen as a job where some people are focused on pipeline and computation, and some people are focused on taking the results of that data and creating knowledge and using that knowledge for a goal in the business or in science. Okay, so some data scientists are more human focused and they're communicators. They're able to tell stories with data and help people who are not quantitatively minded understand the results of the analysis. That's another key feature that we're going to talk about in this course. And some data scientists are more focused on the engineering of keeping track of data, of making sure that the data is good data and not rubbish, okay? Making sure that the data is kept up to date and that the latest information is at the fingertips of the analyst, okay? I do want you to read this article and take a look at the advice on hiring here. I want to highlight this. When Harvard Business Review is telling CEOs who are going to hire data scientists, look for people who love to solve problems. They're not in love with their favorite machine learning method, or they're not just, have a hammer looking for a nail. You want to have somebody who's thinking with the data and loves that process of thinking with the data. You want to look for people who are incredibly collaborative, because even if you're a computer-facing engineer, you need to be able to work with engineers and project managers and function with these teams. This is often, I find a lot of students don't realize this, that they're going into something that they think of as a very quantitative computer-oriented field, and they don't realize how much people skills are really valued out there in the business world. And finally, you are a curator of knowledge that is being used to make important business decisions or important science decisions. If you cheat, well, those decisions might as well have been made by somebody throwing a dart at the dartboard. Okay, so they're really interested in people who have really high integrity, who always dot the I's, who are never going to lie or massage the data. As for instance, recently, I don't know if you're aware of the hubbub in Florida back in probably May, when the data scientist running the coronavirus dashboard for the state of Florida was fired because she had been asked repeatedly to make the numbers look less bad, that Florida's governor was not interested in the bad publicity of many cases of coronavirus. So they fired her and replaced her with a faceless set of people who were going to massage the data and massage the visualizations to make stuff look better. So you want that original dashboard woman. You want that kind of person in charge of your data, who's not going to lie to you with the data, who's going to make sure that the numbers on the dashboard reflect what is being measured, not what politics wants. Okay. So, all right, let's finish up real quick. We have covered a decent introduction. I think we just want to swing back into what's actually going to go on. So everything, as you know by now, is asynchronous in the lectures. I will be recording these and sending them out to you on Canvas. However, during the assigned lecture time, I will be in a Zoom room waiting to chat with you as office hours, or if I have dozens of people at once, I'll run it more like a discussion section trying to answer your questions. There will also be synchronous discussion sections run by our wonderful TAs. Asheen, Avinash, and Vicky are all going to run these discussion sections. If you're not aware already, Asheen is in Ireland, and so his time zone is very different than Avinash, Vicky, and myself who are in San Diego. So he's going to take the early zone, and his time zone will overlap a little bit more with people in China. So you should definitely send messages to him when Ireland is in business hours and you are up and in need kinds of advice or something like that. Okay, if you're up during business hours in San Diego, it's Avinash, Vicky, and myself. And our IAs are, I believe, all in the Asian time zones. So you should, if you're needing information at that point, you can send them emails, or all of us will interact in Piazza. Let's see. Let's go back to. Is that going to work? Yep. Okay, cool. So, this is a survey course. What does it mean that it's a survey course? We're going to get you understanding what concepts are. I'm going to give you examples and tell you stories. We're going to talk about things. We're not going to do them. You're not going to learn real statistics or machine learning in this course. Okay? That is for later. We're going to not do anything programmatic. We're not going to do anything in depth or theoretical. So what we really want to do is we want to define terminology so you understand when people talk about this stuff. Okay? We want to demonstrate how to think critically about data. Because again, I feel like the data scientist's biggest weapon is not the software package they use. It's their ability to think, which will be of use for their whole career, whereas that software package or special technique is going to change throughout their career. Okay? We want to learn how to approach problems with a data-first mindset. Note, I said data first, not data only. Okay? Data is just part of the thing. There are other considerations when making analyses. There may be an idea that the data is not a good measurement of what you want. There may be human factors that have to be taken into account. Okay? But to think about the data first before we go anywhere else. So we want to describe the basics of communicating with data, of using visualization and storytelling so that people can understand the results of the analyses you've done. We want to inspect and work through problems demonstrating various common failures of data science when people end up fooling themselves by using bad procedures and end up p-hacking their way to the results that they want to see. Also, sometimes when people violate very important ethical principles doing data science. We're going to talk a lot about that. We're going to discuss data privacy, ethics, real-world examples. Okay? We're going to cover these topics. We're going to cover them in roughly this order. When you get through all this stuff, I think you're going to find that you're quite familiar with the ideas, and then the rest of your data science education will get you into those theories and how it actually works. Please use Piazza. Please use Canvas. Know that you're going to turn in assignments using Gradescope. If anything occurs during this quarter that you need to tell me about, please do. You can tell me directly to my face. You can send me an email. If you don't feel like you can tell me to my face, then please use the anonymous feedback form. There's a Google form. It's linked on the syllabus. Read the syllabus. And you can use that form without revealing who you are to tell me anything you need, positive or negative, about the course. Discussion section. We have many people in Asian time zones. So if you need to, Asian time zone people, if you want to get to a discussion section synchronously and the one you're signed up for is not good for that time zone, please feel free to switch and go in any section. If you are, however, in the California time zone, I'm going to ask that you not switch section if at all possible, just because that way we can clear up more space for the Asian people to switch over. Okay? Discussion section, we'll discuss the course readings, we'll work on group assignments, we'll get a chance to tell more stories and hear what you think. Grading is fairly simple. If you have any questions about this, please ask. The final project is something that you will do in a group. Assignments are going to be individual. I want to note that an early draft of the syllabus that was left over from a previous quarter said Friday for due. It's going to be Thursday so that we've got everything done before discussion section. Okay? Readings also due on Thursdays. Okay? So the final project is going to be a report on how you would handle a complicated data science project. You'll be given a skeleton to help you work on this, and you'll submit these as PDFs on Gradescope. Okay? So you're going to we'll talk a lot more about this. Right now I don't have time to cover it in detail, but fundamentally you're going to think through all the problems that could arise, all the things you would want to have happen in doing a large data science project. You're going to define the problem, you're going to find the data, where that data exists out there, you're going to describe how you would get it, how you would deal with the data, manage it and pipeline it, how you would run an analysis, everything except actually doing this. Okay? So there will be readings, there will be quizzes. The quizzes will be due on Thursday at 11:59. There's no time limits on the quizzes, and it's open whatever, right? You know, the whole point is just to make sure you actually read it. Exams will cover these first few weeks on October 21st, and then another one on December 2nd. There is no final exam. The final project replaces the final exam. Okay? And there may be some assigned reading questions hidden in there. So once again, if something is unclear, if there's a mistake, if there's a point of confusion, please ask. Especially if it's a point of confusion of some sort or a mistake that you have found, it's a good idea to put it on Piazza, because that way loads of people can see it. It's not just an email to me that I answer direct to you. Okay? And on Piazza you can ask your classmates, and your classmates can answer as well as the instructors. Okay? Finally, I just want to close with this. We in this class are going to abide by the principles of community. This place is warm and welcoming no matter who you are, what you are, how you feel. Okay? We're here for you. Especially in pandemic times, you know, we have to take care of each other. We have to make sure that everybody is feeling warm and welcome. If there is a problem, if you feel uncomfortable about something, you can speak directly to me. And if you're not comfortable speaking directly to me, please go right to the OPHD or CARE, who are offices that are set up directly to help students out in ways that can be handled even if the situation is delicate. Okay? I'm really, really excited to have everybody in the class, and I'm very much looking forward to chatting more with you all in person on Zoom, so to speak, and over Piazza. Thank you so much, and I will see you again next lecture.